Lesson 6.5 is solving special types of linear systems. So in previous lessons, 6.1 through 6.4, you found solutions to a linear system. But now we're going to be able to identify the number of solutions of a linear system. So first, a linear system can have no solutions or infinitely many solutions. In order for a linear system to have no solutions, we know that the lines can't cross. So those are parallel lines if they don't cross. And if it has no solution, it's called inconsistent system. So it's an inconsistent system. And it can have infinitely many solutions if the two equations actually are the exact same line. So if they're the exact same line, it will have infinitely many solutions, and that's called a consistent dependent system. So inconsistent, no solutions, parallel; consistent dependent system, infinitely many solutions. In other words, every single point is a solution because they cross at all points. So in some of the problems, they're going to have you graph it and then decide how many solutions there are, so you'll have the visual. So let's go ahead and look at this one. I'm going to take the top equation and solve it for y. So I will add 6x to both sides, and then I will divide by 2 to get y equals 3x minus 1. My y-intercept is -1, my slope is 3, so 1, 2, 3 to the right, and 1, 2, 3 to the left. And then I'll go ahead and draw my line. Oops. And then the other equation, all I have to do is add 3x to both sides. So my y-intercept is 2 and my slope is positive 3x. 1, 2, 3, 1. 1, 2, 3, back 1. And I already know, without even graphing them, that they have the same slope. So these have no solution. No solution because they're parallel lines. Let's try another one. This one right here, I'm going to go ahead and subtract the 3x. So my y-intercept is 4 with a slope of -3. And the other one, I will subtract the 1x, multiply everything by 3. So y equals -3x plus 6. And it just so happens that this one that we have is another parallel. So again, no solution. In some cases, they're going to say, okay, without solving the system, so don't solve it, they want to know, is there one solution, no solution, or infinitely many solutions? So if they have, and I want you to go ahead and write this down, same slope, different y-intercept, then they have no solutions. If they have the same slope, same y-intercept, they have infinitely many solutions. If they just have different slopes, doesn't matter about the y-intercepts, then they have one solution. So really all we need to do is put both of these in slope-intercept form and figure out the slope and the y-intercept. So the top equation, I will add 2/3 x, and my slope is 2/3. My y-intercept is 2. And then in the other one, I will add the 6x, divide by 3. So y equals 2x plus 2. So my slope here is 2, my y-intercept is 2. My slopes are not the same, so there's one solution, because it's the third scenario right here, one solution. And here I will add the 4x, so 3y equals 4x plus 2, divide by 3, so y equals 4/3 x plus 2/3. Slope is 4/3, y-intercept is 2/3. And here I will subtract the 4, so I get negative 6y equals negative 8x minus 4. Divide by negative 6. Y is going to end up equaling positive 4/3 x, and then plus 2/3 when you simplify it. Here the slope is 4/3, the y-intercept is 2/3, so these are the same line, so we have infinitely many. Solutions. What that means is whatever you put in for x, whatever you put in for y, it's going to make a true statement. Alright, golf clubs. A sporting goods store stocks a better set of golf clubs in both left-handed and right-handed sets. The set of left-handed golf clubs sells for X dollars and the set of right-handed golf clubs sells for Y dollars. In 1 month, the store sells 2 sets of left-handed golf clubs and 12 sets of right-handed golf clubs for a total of $1,859.30. So I'm going to go ahead and set that up. 2 sets of left-handed, 12 sets of right-handed, and their total $1,859.30. The next month they sell 2 sets of left-handed again, now 22 sets of right-handed, and their total is $3,158.80. And they're asking, is there enough information to determine the cost of each kind of set? Well, if I went to solve this, I would end up subtracting. So I would subtract, 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 and then turn around and add it. So I would end up with negative 10y equals, I've got the 1859.30, subtract 3158.80, and I get negative 1,299.5. I can stop right here and say, yes, there's enough info. Because the system is able to be solved. With one solution. They're not asking for the solution, so I'm not going to finish it. But as long as all my variables don't drop out, then I'm good. If all of the variables dropped out, then I wouldn't be able to figure out what the x and the y are. Let's look at this last one, comedy tickets. The table below shows the ticket sales at an all-ages comedy club on a Friday night and Saturday night. So Friday night, they sell 30 adult tickets, 20 student tickets, and $910 total. Saturday, it's 45 adult, 30 student, and 1,365 total. So they're saying let X represent the cost in dollars of one adult ticket and Y is the cost in dollars of a student ticket. And they want us to go ahead and write a system. So 30X plus 20Y equals 910, and 45X plus 30Y equals 1,365. So we solved the system. And at first glance, I can't tell whether I can actually figure out X or Y because we don't have exact same or exact opposite terms. So I'm going to use multiplication, and I'm going to look at the 20 and the 30. I know their least common multiple is 60, so I'll multiply this by a 3 and this one by -2. When I do that, I get 90X plus 60Y equals 2,730. And the bottom one I get -90X minus 60Y equals -2,730. Well, I have opposites everywhere, so if I add, I end up getting 0 equals 0, which means there's infinitely many solutions. I don't know why I cannot spell infinitely today. There we go. Many solutions. If everything dropped out and it was a false statement, then there would be no solution. So if it dropped out and we had 0 equals 1,500, that would be no solutions. But here everything dropped out and it's a true statement. So I solved it. And can you determine how many of each kind of tickets, how much each kind of ticket cost? No, because there are infinitely many solutions. So we cannot determine the cost. Alright, I don't have an assignment worked out for you yet, but I will get you one by the time you take the notes, and then if you want you can just look at the website.